And so this bar's done a crap video, just schlocked something together. So in this case, the masses he's putting on the lever probably don't weigh more than the lever, so that's really bad. You want it to be like at least a 10-to-1 relationship.
No, Gary, you're wrong once again. The bar has a mass of 38.50 grams. These weights have a mass of around 58 grams.
And the weights aren't attached. I mean, you can just go on and on.
So now I actually fixed the weights with tape to the bar. It's now actually stuck. It's not hanging loosely on the bar. And I'm using 2 weights as a one mass. So we have roughly 120 grams as our one mass, while the bar only weighs 38.5 grams. All right, let's check out. So one mass, 4 distances. 100. 98. 96. 98. 95. 95. 97. 96. 97, right? So it's between 95 and 100. Well, the fastest are around 95, okay? So now I got 4 of these attached with tape at the 2 distance mark. All right, let's check it out. 72, it's going faster again. 73, 72, 73, 74, 73, 73, 72. Why is that? Why is it going faster again? Huh? Look at that, look at the rubber band. It's always the same amount of energy input, right? The rubber band is attached with tape. The rubber band is attached to the nail over here, to the wooden block. The wooden block doesn't go anywhere. We always have the same, right? The fulcrum is perfectly in the middle. Tell me, what's wrong with this lever system? Just pulling it back, the rubber band, make sure that it is launched. And what do we see? Each time the same result. You want a quick release? Here's a quick release. All right, 4 mass, 1 distance, quick release. All right, timing 75. Okay, quick release for the 1 mass, 4 distance. 100. Does make a damn difference.
Brozo is supposed to have done the experiment also, so I'll wait for his video. We'll see what kind of piece of shit it is.
Oh yeah, and why do you want to focus now on Steve's experiment? Every single experiment he does is also garbage according to you. Every single time you keep complaining that his camera is absolute crap quality, but look at mine, my camera is good quality, and I have the fucking timers. That's supposed to be accurate. I got consistent results every time. You don't have to use you don't have to count the camera frame rates, alright? You don't have to deal with any of that. You just, with the timers, it's simple. What is more accurate? Using timers or counting frame rates with a crappy camera? Huh?
Shenanigans. So Despard did it with washers that are not heavy enough, and he also has it going very fast again for no good reason. And and the washers aren't attached; they're loose. So the washer, the hole in the washer is 3 times the size of the stick going through. So obviously, in gravity, it sits on top of the stick, and then when it moves this way, it has to rotate the object to push it. And so obviously, it has to lift it if it's going to do that. So lots of room for screwing up the equalities of the experiment, the ideal of doing things equally.
So again, the one mass at the 4 distance place has a timing of around 100, 101, 101, 102. All right. So now let's see how far we have to move the 2 distance more to the further out on the lever, such that it will have the same result as a 1 mass at the 4 distance. So this is the 2 mass once again at the 2 distance, and we have, it's going faster, right? 77, 77, 77. So now let's move it further out. Let's say over here. Now we're getting closer to 100. 100. 100. 100. 100. So you see, 103. There we go. 103. So this is the spot roughly. I have to move it, so instead of over here, I have to move it more until this point to get the same result as a 1 mass at twice the distance, at 4 distances. So we have 1 distance, 2 distance, so like 2.5, a little bit more, a little bit above 2.5 times the distance. Not 2 distance, but 2.5 or a little bit more. Okay, so let's now measure this position. Seems to be around 31 centimeters. And the 1 mass twice the distance was at 47 centimeters. 47 divided by 31 is 1.5 or 1.51. Ideally, it should have been 1.41. Okay, so ideally you would have to put the 2 mass 1.41 times further from the fulcrum. Okay, so if this is 1 distance and this 2 distance, the 2 mass should be at 1.41 times the distance from the fulcrum to have the same angular speed as a 1 mass at twice the distance from the fulcrum. That's what the theory says, and that's what more or less has been demonstrated here experimentally. Okay, so what's next? What do you want me to change now about the setup? Because I'm convinced it's going to prove you wrong as well. Again, and again, and again, and again, and again, Gary. It's always proving you wrong. How is that possible? Why does it never come out your way? Because it's a crap experiment. It's a crap setup. If it's done clinically, it will be coming out your way. What way? What do you want me to do? Do you want a golden bar? Do you want it to happen in a vacuum? What else do you want me to change now? Huh?